Kevin Omar Lopez Castellanos, and we're going to be going through the next two protocols for Service Group 2. That's going to be IMAPS and DNS. Let's go for it. We're going to be discussing the two protocols. I'm going to show you all how to configure them, suggestions on how to harden them, and we conclude. Let's examine these. So, as with most of the protocols that we dealt with that end with S, this is a secure version of the original, which is known as IMAP or IMAP, the Instant Message Access Protocol. It's another protocol that's meant to handle the retrieval of emails, but the difference is that it treats it as if it's a local storage device. What that means is we can access multiple clients and talk on the same account from the same server from anywhere. In a way, you can think of it as sharing Netflix accounts or a Hulu account, you know what I mean? And IMAP is when combined with SSL, or as we already know, modern day TLS, it becomes secure, allows it to be protected with encryption at the transport layer. With that, it can ensure all traffic travels through secure ports. The default port for IMAP is 143, as you can tell from the diagram. But with the secure section, you can assume that an SSL certificate is placed and the encryption does its job, ensures that any traffic that goes in between the ports, through the traffic lines, through the transport layer, is secure, encrypted, and even if it is intercepted, is nothing but pure garbage to the viewer unless they have the encryption key. Typically, this protocol is configured at TCP port 993, so keep that in mind as we're going to move on how to configure our servers with them. Go to domain name system. You know how we're able to use the IRLs and the domain names in order to access certain web pages? That's because of this system. Instead of having to memorize the IP addresses and the port numbers, these act as our logical addresses. And it operates under two types of messages. Queries, which are also known as the requests for information, taking us to the location where we can retrieve it. Then there's the replies. So you can consider this protocol the phone book of the internet. You know how back in the old days we'd use a phone book in order to locate somebody? That's what the domain name system does for the cyber world. Translates the domain names to IP addresses, and with the IP addresses, a system can then locate a resource and retrieve it for us. So how are we going to configure these protocols for Linux and Windows? Let's go for it. So in order to configure the IMAPS protocol for the Ubuntu server, we're going to be doing it on Dovecot. So make sure to keep that in mind, and make sure to keep this image in mind when we're about to go further into this. So first, you got to enable the IMAP protocol on the server. So make sure that the core package is installed if you haven't already, and there's an extra section in this Linux command that allows you to enable the IMAP protocol. And if you remember from the last video, we use this text file in the next command in order to enable SSL, and we do the same thing as before. We enable SSL, we leave the certificate section blank, so that way by default the secure socket layer uses a self-signed certificate, and thus we don't have to configure one for ourselves. So in order to harden this protocol, I would suggest, again, referring to the image above first, you go to the text file, you add in another line known as protocols equals IMAP to further enable the IMAP protocol, and change the SSL yes option to required. This will enforce the encryption, ensuring that it's not just permitted, it's mandatory in order to process through the system. And I left this image as instructions below on how to use a self-signed certificate. And if it's too hard for you to see, I left it in my slideshow, the actual presentation file. How are we going to configure DNS for the Windows server? So The instructions are as below. You open the server manager and you go to the Add Roles and Features section. You click Next on the page that follows. Find the option that says Role-Based or Feature-Based Installation. Select Server to install the DNS and hit Next. Next, we're going to select the DNS server and add its features. So click on the Add Features, select Next on the 3 consecutive screens that are coming. So when a new screen pops up, that's number 1. The next screen, number 2. Then the third screen, number 3. Afterwards, you select the server to install DNS and hit Next. Then you got to confirm your selections and install it and wait for it to load. Once it's finished loading, you hit Close and you have it configured for the server. Now for the Ubuntu server, how we're going to configure DNS is by using the bind9 program. So first, you got to make sure your server's updated. Then use the second Linux command below in order to install bind9. Make sure it's working. So use the Linux command that's right below ns-lookupgoogle.com with the IP address, and the answer should look like the image below. Then there are these specific instructions below, further providing these Linux commands in order to configure DNS for the bind9. I'm not the best at describing these instructions, so just make sure to follow exactly what this slide tells you to do, and you'll be able to configure the DNS using bind9 for the Ubuntu server. Now, here are some recommendations for hardening the DNS protocol on the Windows server. What we're going to do is first, DNS cache locking. It's going to allow us to control when information on the DNS cache can be overwritten. What that means is that results usually are cached and are stored in the cache so that if we have to repeat the same request, it can load faster. Once the results are cached, response time to other queries can remain fast and thus not create so many redundant queries. How long a DNS server keeps this information in the cache is determined by the value that we know as time to live. So whenever we're going through a server or a command line, we can usually find this quality when we're pinging or using an IMAP to determine the qualities of certain packets. So make sure to keep that in mind. Next is the DNS socket pool. We have to enable a DNS to use randomization when it issues the DNS queries. What that does is that we gain random requests. With that, we can make these cache tampering attacks more difficult because in order to successfully launch a cache tampering attack, you have to know the exact source port of a DNS query and its ID. But when you randomize those two for every query, it makes it that much harder to determine because most people will be looking for patterns when they're trying to discover a vulnerability in your system. But by ensuring that the source port of the DNS query and the random transaction ID have to be correctly guessed, the possibilities of them correctly guessing your exact two qualities is very difficult. That makes it harder to crack through conventional means, such as a dictionary or brute force attack. Next is the DNSSEC. What that does is it enables a DNS zone, and every record of it is signed cryptographically. As we know, encryption is becoming much more necessary in today's security world. So this would allow an authentication necessitation towards this. And I'm probably using very confusing English, but what this means is that the client computers have to validate the DNS response because we could be potentially getting a DNS response that could be a spoof. You know, DNS spoofing attacks are very common now these days. So by allowing us the opportunity to validate the response, we can prevent more intrusions. How do we harden the bind9 for the Ubuntu server? What we do is that first we got to test the server and see that it's working properly, because if we don't even know if it's working properly, how are we going to proceed with the next issues? Next, we got to configure them as primary and secondary DNS servers. Make sure they have the the top jobs in having the identity of mandating and processing the DNS protocol for the system. How to do that is very complicated and beyond the time I have to share on this video. But if you go down to my works cited page, you'll find many links that lead you to By9, and on the particular web pages, they will include instructions on how to configure them as the primary and secondary DNS server. So I highly recommend you go to those sources if that's what you want to do to further harden By9 for the Ubuntu server. Here are all my resources, and as I said below, the last two links will contain the information you need to further harden the By9 server. So I leave that up to you, and thank you for hearing me out. And that's the end of my little lecture. Hope you have a good evening. Goodbye.